Okay, this problem will clear all the basic properties and all the basic fundamentals for drawing the root locus. Okay, now the first problem in this is, if location of poles as well as 0 is given as plane and we have to decide the root locus. Zero here, one pole here, another pole at -3. So all poles and zeros are lying on the j omega axis. There is no complex conjugate pole. So for this, if I want to find the root locus, see, the first thing is number of asymptotes equal to 2 minus 1 equal to 1. That means only one asymptote which will terminate at, which will go to infinity. Okay. Now if we closely look at the location of poles and zeros, we have to see the region in which the root locus will lie. If you look in this region, then any point in this region number of poles plus zeros are odd on the right hand side of this region. Number of poles plus zeros on the right hand side of this region are odd. That means root locus will lie in this region. Okay. If we look in this region, let this be region number 1, this be region number 2, and this be region number 3. If we look in this region number 2, then number of poles plus zeros are even. So in this region, root locus will not lie. If we look in this region, again number of poles plus zeros equal to 3, so root locus will lie in this region. The present position is given for k equal to 0, k equal to 0, and here also k equal to 0. Now if k is increasing, so what will happen? Poles will terminate to 0 or to infinity. Okay, so now here there are two poles and single zero. So out of two poles, one pole will terminate to 0, other pole will terminate to infinity. Okay, so this pole will move towards infinity and this pole will move towards 0. Now see, the pole which is terminating towards infinity has got one asymptote which is again the same. That's why the asymptote is 1. Number of asymptote here is 1. So if I write open loop equation for this, suppose GSHS equal to k times of s minus 1 upon s plus 3 s plus 1. If I want to find the intersection of the pole with j omega axis, I can use Routh-Hurwitz criteria, because up till here for k equal to 0 value, this system is a stable system because the poles are lying on the left hand side of the j omega axis. But at some value of k, this pole will lie here. Okay, when this pole will come at this position, at that time one pole is lying on the right hand side of the S-plane. So when the poles are on the right hand side of the S-plane, that will make system unstable. So using the Routh-Hurwitz criteria for stability and instability, we can use it to find the value of k for which system is becoming unstable. Instability. Okay. Another problem. See, again in this, the location of poles and 0 is given. Generally if a question comes in gate exam, it will be like this only. J omega axis. Two poles are lying on the right hand side and two zeros are lying on the left hand side of the S plane. Okay, minus 1, minus 3, plus 1, plus 3. Okay, sorry, this is plus 1, plus 3, this is minus 1, minus 3. For this, I need to find the root locus. Solution. My GSHS is equal to K times of S plus 1, S plus 3 upon S minus 1, S minus 3. So I can see that since the poles are lying on the right hand side of the S plane, this is a unstable system. Okay. Now, whether it will be stable at certain value of K or not, we have to find out. Okay. So for that we can use the Routh-Hurwitz criteria. Okay. Before going for seeing the Routh-Hurwitz criteria, we will see how we can plot this. See, in this, if we look, let this be region number 1, this be region number 2, this be region number 3, this be region number 4. Okay. In region number 1, to the right hand side of region number 1, there are sum of poles plus 0 is 1. So definitely root locus will lie in this region. Okay. If we look in region number 2, in this region, number of poles plus zeros lying on the right hand side of the region is 2. That is, they are odd, even. So once they are even, so in this region there will be no root locus. In this region again root locus will be there, because in this region also number of poles plus zeros are odd. So now zeros will remain at their positions. Number of poles is equal to number of zeros. Only the poles are there which moves, not the zeros, because we are finding the roots of 1 plus GSHS. Okay, so that becomes changing the position of poles. Now since poles are together, so both poles will try to come close to each other. At certain point both poles will meet. After that they will break apart. So when the poles will break apart, they will go to two zeros present. Okay, because if number of poles equal to number of zeros, so from here I can write number of asymptotes equal to 0. That means there is no single pole which will terminate at infinity. Both the poles will terminate at both zeros. So the poles will break apart from here and they will reach certain point here. And from after reaching here, these poles will, one pole will move towards the 0, one pole will move towards the 0. Now to find what is the breakaway point in this, okay, we can again find the breakaway point using dk by ds equal to 0. Okay, we will see that. I am having my GSHS is equal to k times of s plus 1, s plus 3 upon s minus 1, s minus 3. Okay, so k equal to minus of s minus 1, s minus 3 upon s plus 1, s plus 3. Okay, so tk by ts is equal to numerator minus outside differential of denominator. It will be 2s plus 4 minus 2s minus 4. Okay, equating this equal to 0, we will get three values of S, S1, S2 and S3. Okay. So now solving this and finding the value of S1, S2 and S3, one value of S1 will be lying between these 2 points, somewhere here. One value of S will lying somewhere here. Another value of S will be lying somewhere here. That value is not useful. Okay. So the value which is lying here and here, they are the useful values. So in this way we can plot the root locus for such problems. Okay. Now one more problem, a simple one. In this, location of poles is given on the j omega axis. One pole is here, another pole is here. How to find the root locus? See, number of poles 2, number of zeros 0. So asymptote will be 2. Since there are no zeros, so both the poles will terminate to infinity. Okay, the angle of departure of these poles will be 180 upon number of poles. Number of poles are 2, so it will be 2. And it will be 180 upon 2, which is equal to 90 degree. So one pole will move away, another pole will move this side. So this is a root locus in case of this system. Since there are no zeros, so they will terminate at infinity. Okay. Again one more problem. A statement is given, forward path open loop transfer function of a unity negative feedback, important. Only GS is given. K times of S plus 2, S plus 6 upon S square plus 8S plus 25. Okay, we have to find the root locus of this. Okay, solution. First, S square plus 8S plus 25 equal to 0. If I solve this, I will get S equal to minus 8 plus minus under root of 64 minus 100 upon 2. So minus 4 plus minus 3j. These are the poles of open loop system. Okay, zeros are minus 2 and minus 6. So if I plot this on the S plane, plus j3 minus j3. Okay, 1 0 at minus 2, another 0 at minus 6. Okay, so zeros have come. Now poles at minus 4 plus minus 3j. So one pole at minus 4 plus 3j, another pole which occurs in conjugate pair, minus 4 minus 3j. Okay, now so we have decided the locations of poles and zeros. So 2 poles, 2 zeros. Number of poles is equal to number of zeros. Thus number of asymptote zero, because poles are equal to zeros. Angle of arrival, angle of departure, since these two poles are there, these two poles will terminate at two zeros. So the poles will start moving from here towards this. Both these poles will come together here. After coming together here, one pole will move towards this side, another pole will move towards this side. Okay, so this is the way root locus is drawn for this system. Okay, so once again we will see, we have find the location of poles, we have find the location of zeros, two poles, two zeros, the now two poles will terminate at two zeros. So number of asymptotes are 0. Angle of arrival, angle of departure will be 180 divided by number of poles. So it will be 180 divided by 2, which is equal to 90 degree. Okay, so this is 90 degree angle of arrival. Okay, it's also 90 degree. After arriving at some point, these two poles will move towards two zeros. So in this way they will terminate at zeros. Again one more problem. Problem number 5. Forward path transfer function of a unity negative feedback system GS is equal to K times of S plus 6 upon S plus 3 upon S plus 5. Okay. Now for this we have to find the breakaway point and break-in point and also the root locus. Of course we have to draw that. Simple, you can easily find the poles and zeros. 0 is located at minus 6, one pole is located at minus 5, another pole is located at minus 3. Okay, now number of poles equal to 2, number of zeros equal to 1, thus number of asymptotes equal to 2 minus 1 equal to 1. Okay, now number of asymptotes have got 1. Now what will happen, out of two poles, one pole will terminate at this 0, another pole will terminate at infinity. Okay, first if we look at the number of poles and the region, root locus will lie in this region and root locus will lie in this region. It will not lie in this region. Okay, so we have to find the breakaway point and breakaway point and break-in point. Breakaway point means when the two poles will come together and move apart, and break-in point when the two poles are coming, the point at which the two poles are coming in and moving and then moving apart. Okay, so for finding the breakaway point, since it is a unity negative feedback system, 1 plus GS equal to 0, so K equal to minus of S plus 3 S plus 5 upon S plus 6. So dk by ds is equal to S plus 3 S plus 5 minus S plus 6 to S plus 8. Okay, we have to equate this to 0. Whatever comes in the denominator, that is immaterial, because when this will go to here, it will become 0. So finding the roots for this, I will get the value of SS minus 4.267 and minus 7.732. Now the breakaway point and break-in point always lie on the root locus. Okay, so the first value minus 4.267, minus 4.267 lies between minus 3 and minus 5. Okay, it is somewhere between this point, minus 4.267. So definitely at this point two poles are coming and they are moving apart. They will move at an angle of 90 degree, then they will deviate and come towards 0. Okay. Another point is minus 7.732. Minus 7.732 will definitely lie another again here, 7.732. Okay. So at this point these poles will come. Okay. After coming at this point, one pole will go here, another pole will terminate to 0. So this is the breakaway and break-in point, and this is and the root locus diagram for the given question. We have to solve this quadratic equation to get the value of S. One more question. In this, we need not to find the root locus, but we have to find the angle of asymptotes. Forward path transfer function of a unity negative feedback. Gs equal to k times s plus 3 upon s into s plus 1, s plus 2, s plus 4. We have to find angle of asymptotes. Okay. Now, number of poles 4. Number of zeros 1. Then number of asymptotes 4 minus 1 equal to 3. Okay. So for angle of asymptotes, one 180 2k plus 1 upon 3. That means 60 times of 2k plus 1. Okay. K value can be between 0, 1 and 2. So theta is equal to 60 degree for k equal to 0. Theta equal to 180 degree for k equal to 1. Theta equal to 60 into for k equal to 2. 60 into 5, 300 degree. Okay, for k equal to 2. So these are the angle of asymptotes. Okay, so these type of problems are also asked from the topic of root locus. Directly they will not ask to find the root locus, but they will ask certain other things. Okay, one more problem. In this problem, root locus is given. We have to find the intersection of root locus with the imaginary axis. Okay, root locus is given something like this. Or instead of root locus, we will just see the poles are given plus j minus j minus 1 minus 4. Okay, for this we have to find the intersection with imaginary axis. Find intersection of root locus with imaginary axis. Solution. For finding the root intersection of root locus with imaginary axis, we have to follow the Routh-Hurwitz criteria. Okay. For looking the Routh-Hurwitz criteria, we need to know the characteristic equation. Okay, so now assume that this is a unity negative feedback system. Okay, so in this case I can write poles are located at -4, -1 plus minus j. So one gs can be written as k times s plus 4 s plus 1 minus j s plus 1 plus j. Okay, so this can be written as k upon s plus 4 s square plus 2s plus 2. Okay, so this will become k upon s cube plus 6x square plus 10s plus 8. Okay, this is gs. So what is 1 plus gs? This will be s cube plus 6x square plus 10s plus 8 plus k. This will be my characteristic equation. Okay, we will exclude the denominator part, take only the numerator part, because 1 plus gs is the denominator of that. Now from this we will make a Routh array and we'll find the value. Characteristic equation x cube plus 6x square plus 10s plus 8 plus k. For this my Routh table will be 1, 10, 6 and 8 plus k. This will be 60 minus 8 plus k upon 6. Okay, this will be 0. This is again 8 plus k. Okay, so this I can write this term as 52 minus k upon 10, sorry 6. Okay, so for marginal stability 52 minus k upon 6 equal to 0. When this is equal to 0, that means my entire row will be 0. When my entire row is 0 again, that means it has become marginally stable, or there are some poles, there are some roots on the imaginary axis of this characteristic equation. At that time I will get the value of k is equal to 52. Okay, now using this value of k I will solve my auxiliary equation. 6x square plus 8 plus k equal to 0. 6x square plus 60 is equal to 0. So s square equal to minus 10, s equal to root minus 10, which is equal to plus minus j 3.162. So at this value of s, it crosses the imaginary axis at s equal to plus minus j 3.162. root locus crosses the imaginary axis. Okay, so these were the few problems from the topic of root locus. We will study all the problems of control system while we solve the problems which has appeared in GATE exam. Time being we will solve the problems which have come with, topic wise, the topics which we are covering, and then we are discussing the problems. We'll cover more problems from the root locus when we'll discuss the problems for the problems which have appeared in GATE exam. Okay.